good morning, or maybe good night, whatever time you're watching this. Welcome to another Kerbal Space Program video. Today, we pick up right where we left off in Chapter 4 of our self-funded space program series. As a note, I will soon start referring to this series with a different name, because of course, funds are a means to achieve a purpose, not an purpose in itself, but well, we'll talk about that later. Now, we resume our operations on the lunar surface. Before leaving, we had the purpose of placing a series of deployable experiments that will provide research points as time progresses. I certainly have doubts as to whether the seismograph works the same way as in stock, but I will take the time to bomb Mun later with a battery of guided missiles for sure. With everything installed, we returned to our module and took off again towards Nymeria to continue our mission to MINMUS. Although the rendezvous was not necessarily ideal, since for scanning purposes, the Nymeria was positioned in a polar orbit, the NERV rockets are very efficient and were able to adjust our orbit. Time is of the essence, so at the cost of a little more delta V, we seek a faster interception, to avoid prolonged exposure to Kerbal radiation. Once on the Nymeria, our crew encountered an important dilemma. The cost of Delta V at this stage of the mission had been quite high, which could make it risky to continue our mission to MINMUS, since it would make our subsequent entry into Kerbin's orbit and eventual return home quite difficult. Despite the danger, the decision was made to continue towards MINMUS. There were just over 3,000 of Delta V left, and MINMUS is a small enough moon for us to be trapped on it. So, we stopped thinking about it and activated MechJeb's artificial intelligence to calculate the most optimal maneuver node. This would not put us on an interception trajectory directly, but with a simple adjustment halfway we would start a course towards MINMUS spending just 350 Delta V. Approximately 30 days would pass before starting the combustion, which would give us time to extend our mapping operations on the surface of Mun, which would be approximately 80% complete at the time of our departure. Meanwhile, we finished the trip from our Selene research outpost to MINMUS, which, as planned, would arrive long before the Nymeria ship. It certainly seemed somewhat tedious and complex since I myself did not remember the configurations or stages that I had prepared for this trip, so I did this entire route blindly. I even thought that I had made mistakes. When I was finally able to land, I was happy to know that I could at least trust myself a little. The most complex part came now, and it was discovering that landing was just completing the contract. The idea of this outpost was to assemble automatically once on the ground, or to wait for the arrival of an SCV to support this construction. Since I still do not have any operational SCV prepared, I decided to carry out the assembly automatically. After all, we only have 2 modules. Don't worry, in future videos I will show you the SCVs if you don't already know them. I have plans to use them in future mining operations as medium-sized vehicles, just like the mules. Okay, the outpost is set up, there's nothing else to do here for now. Now the mission continues with the Nymeria. So far everything is going smoothly on our trip, the engines have not broken down, and the crew members have only received moderate doses of radiation. 27 days after landing in Mun, the ship starts its engines once again, now to head towards MINMUS. After our first landing, operations at MINMUS would be routine at least. We had already used our deployable equipment in MUN, so operations here would be based solely on writing reports and taking Earth samples. Our visit would therefore be quite brief, however very entertaining. While the walk in MUN felt pleasant, walking in MINMUS made you feel Superman, or more specifically, Super Kerbal. In a single jump, without using the EVA thrusters, we could even cross the lander to the other side. Sorry for the tourists inside, we didn't bring spacesuits for all of them, so they'll have to settle for jumping in their seats. The last thing we did before finishing taking samples was to inspect the condition of the module's nerve rockets. It was even necessary to service one of these, since its risk of failure had increased after so much use. After this, we were ready to finally return home. To enter orbit and dock with the Nymeria again, we only had the low gravity of MINMUS in our favor, because frankly, I did not count on the rotation speed of this moon. It was something that I had not realized before. In little more than 1 hour, our position with respect to the orbit moved almost 90 degrees, that is a lot. The last thing we wanted was to prolong our time here, so as we started takeoff at the first opportunity, even though that would cost us a little more delta V. At this point was where things began to get complicated and problems began to arise. Now you can appreciate how important it is to always test when playing Kerbalism. While we carried out the interception maneuvers, everything flowed without complications, until the moment we arrived at the ship, and the battery power began to run out quickly. The solar panels we installed were too small, they were barely enough to power the life support alone. If you added the SAS system along with the reaction wheels, the batteries ran out too quickly. And to put the icing on the cake, the right rotation RCS were not placed. This was the part that confused me the most. Even now I could assure that I placed the RCS rockets correctly. I even checked them several times, but somehow, these were not here now. I don't know if it was because I lost the symmetry when I combined both models, or maybe I selected the wrong craft file, but the fact is that once the batteries ran out, the control system became completely inefficient and increased its rotation towards the right with each movement, because the reaction wheels were turned off. To achieve docking, we had to resort to an unorthodox method, taking advantage of the energy generated by nerve rockets. This cost us some additional delta V, but at least we were able to replenish the batteries enough to dock with the ship. The passengers will be happy. Not only did they go to space, but they also had an acrobatic show. Finally, after several minutes, we managed to dock with the Nymeria. But when I was about to celebrate my victory, I realized that I docked incorrectly. This is because I did not realize that the Nymeria was upside down with respect to MINMUS, while I was doing the maneuvers with the module with respect to MINMUS. This was not a big problem, just another annoyance that we had to solve, because the module was not centered with the ship, and would cause an imbalance that would cost us to reduce the power or more RCS fuel needed. So once we refilled the batteries, we undocked again and adjusted the position of the module. Returning home was an inadequate task to say the least. We were in polar orbit around MINMUS. This was clearly a mistake, because although I did it in order to scan part of its surface, I did not count on the rush I would have to return in order to avoid prolonged exposure to radiation, so that I would not complete these experiments, and we lost at least 500 delta V for no reason. Fortunately, I made sure to make this ship foolproof. During the journey to Kerbin, which lasted 9 more days, one of the nerve engines was damaged. I assume that the slight increase in stress among the crew may have had something to do with this, since stress progressively increases their chances of making mistakes, and cause damage to the ship. One of the engines was repaired, while at least half of it required maintenance to prevent future failures. After this, Bill, our engineer, boarded the ship again to await arrival at Kerbin. Regarding the landing module, we had no alternative but to discard it and recover it for later replacement. So after placing the Nymeria in a relatively safe orbit outside the radiation belts, because the delta V was not enough for a lower orbit, we launched a rocket with a parachute equipment to recover it safely in Kerbin. In order for the batteries not to run out during deorbitation, it was necessary to turn off all the water recyclers and stop all the antenna transmissions, otherwise the ship would shut down, and the passengers inside would begin to slowly freeze. In addition, we could not deploy the landing legs. With this you have an idea of how subtle design errors can make an entire mission go down the drain in Kerbalism plus JNSQ. Unfortunately, we lost the experiments that were at the bottom of the module. It was certainly not in our plans to recover it in this way, and by not having experiment containers in other sections, we lost the samples saved in the materials module, but it is not something too relevant considering that later I plan to establish another base in MINMUS for experimental purposes. Although it may not be the best place to extract water, we know that there are minerals, and its low gravity seems the ideal environment to test SCVs there, both for construction and extraction tasks. I can't promise it yet, but maybe in 1 or 2 chapters I'll put them into practice in a more realistic scenario. Today's video ends here, from which we can draw some relevant conclusions. The first, that I am a better engineer than a pilot, of that there is no doubt. The second, the contracts in this configuration are not worth it, because while we recovered almost all of the funds from the launch, it was at the expense of completing 3 contracts at once, landing on MUN and MINMUS, and the outpost bonus that we didn't even count on. Even so, we ended up with 200,000 less funds than we started with. I took the tourist contracts as a test, but I definitely regret having taken the scanning assignments in Ike. Actually, I only took them out of confusion, since I thought they were for MUN and MINMUS. In any case, these can wait, since now I will dedicate myself to improving my mining operations, and subsequent modification of my ship in orbit, since it is clearly not yet capable of a mission of 2 years or more to Duna. I hope you enjoyed. See you in the next video. And of course, remember to like and subscribe to know when the next one comes out.